Hello everyone. Today I'm going to share my experience constructing knowledge graph from Sharepoint site so that the document structure is properly preserved and to enrich it with additional data. First, let me introduce myself. I'm Arif, source engineer of Neo4j based in Indonesia. Now to the agenda. Firstly, I'll discuss about the challenges on getting the data itself. To create the knowledge graph from SharePoint site. And then secondly, I'll explain why Microsoft Graph API can help us to overcome those challenges and how to do that. And lastly, I'll walk through the approach that I have done. Challenges. So the first and naive approach to get the content of a site is by printing it as a PDF. So as you may already aware, extracting PDF content is hard, especially if the document structure has a complex structure. Especially if the document has a complex structure. And more often than not, we also face problems with the extracted content accuracy and also problems with the encoding. And another approach is to scrape the web page directly. This is better than scraping PDF, but we also have another set of problems. So firstly, the HTML structure might change anytime, thus breaking our script. Secondly, it is not easy to work with dynamic content and also with JavaScript rendering. And last but not least, we can only get information presented in the HTML. We miss additional context from other Microsoft 365 services. But I argue that there is a better alternative to get the site content, that is by using the SharePoint API provided by Microsoft Graph. So what is Microsoft Graph and how can we use it? Microsoft Graph is the gateway to data and intelligence in Microsoft 365. It provides a unified programmability model that you can use to access the tremendous amount of data in Windows, enterprise mobility and security, and especially in Microsoft 365, including SharePoint. So with Microsoft Graph, we can do many things like to connect to our data and build custom applications, and then analyze and augment data from Microsoft 365, and to access and manipulate user resources, user collaboration, and so on. Before we discuss about the SharePoint API provided by Microsoft Graph, let's look at the key components of SharePoint itself. So at the top level, we have SharePoint site, the workspace to organize your content, and then knowledge base in the SharePoint site may be arranged as multiple pages, and each page may contain web path. Web path represents a specific web path instance on a SharePoint page, and there are two types of it. First one is the text web path, which represents the text instance on a SharePoint page represented as HTML, and the rest is standard web path, typically used to display rich content like images, documents, videos, lists, and so on. So on the left side is the SharePoint API provided by Microsoft Graph. So you can do many things with it, such as getting the data of various components from your site, create and delete resources, and so on. And in order to build our knowledge graph, two information is needed from the API. Firstly, we need to get the site's ID. And secondly, using the site ID, we can retrieve all pages created under that particular site. And on the right side is an example of the page content in JSON as retrieved from the Graph API. And this is the basis of my talk today. So this is the approach that I did. And before I start, I have put all of the scripts and notebooks in this repository. So feel free to scan the QR code or type it on your browser so that you can access it later. And this is the SharePoint site that I use for the demo. So this is a knowledge base from a fictitious company who sell IoT solutions. They provide three types of IoT solutions, XYZ Firon, and then XYZ Asset Performance, and XYZ Manufacture. And each product has its own dedicated page. For example, this is the page for the IoT Phylon, the environmental monitoring solution. It has multiple web part components like the document attachment, and then this is the IoT asset performance page for the asset performance solution. And lastly, this is the IoT manufacturer, the smart manufacturing IoT solutions. For this page, aside from links to other documents and images, it also has an image of the troubleshooting process that I'll come back later. And the objective is to create a knowledge graph based on those pages and to preserve the document structure. So for example, here, this is the IoT Phylon page represented as this node. And then I structured the web parts that links to each other, starting from the title area, call to action, text, and so on until the end of the part. And then I also connect the external entities mentioned in each part, so that we can have a connection with the external entities as well. So this is the final graph that I have created based on those 4 pages, and it consists. The process consists of 3 steps. The first step is to retrieve the data itself from the Sharepoint API provided by Microsoft Graph, and you can get you can see the code in the repository. So this is the main.py that I use to scrape the data from Graph API, and then there is another Python script called graph.py. Basically, it contains the helper class to connect to the Graph API, and then the result of the scraping is stored under data folder. So here you can see there are 4 JSON files. Each JSON represents the content of the respective page. So for example, this is the representation of the home page, the home.aspx. So you can see here it has an attribute web parts which contain all of the web parts of the page itself. So after getting all of the page data, the next step is to load those data into Neo4j. So there are 3 steps here. The first one, or the most complex one, is to define how to construct text from each web part type. For example, in text web part, the text is represented as an HTML, so we need to strip off the HTML. And then for standard web part, we need to describe how to represent those the rich content as a text. In this notebook, load data notebook, I define a specific method to parse each web part. For text web part, and then for standard web parts, I define some of it. And then after we define how to construct the text, next is to load it to Neo4j and then create the nodes and relationship. So as usual, we create the necessary constraint first, and then we create the web page node and then web part nodes. And here I use a next relationship to connect between web parts so that they represent the order as in the page. And then I create nodes of the external entities linked to each web part, and create a link to relationship to connect those external entities with the respective web part. So the final result would look like this. So this is the IoT environment solution page. The web part starts from here, and then which is the title area, and then next after it is the call to action web part. And then after that, the text and so on. So we can trace the order of the web parts from each page. And the last part to load the data is that we can enrich the graph with the additional data. Like for example, before I showed about the image defining the troubleshooting workflow. Although this is helpful for the reader, but it can be difficult for the reader to search it because it is represented as an image. So we can leverage LLMs to add image description. So here, for example, I get all of the images from the graph, and then I use OpenAI to help me generate automatic description from each image. So here, for example, from the workflow, OpenAI helps me to write this description so that users can search it later. Now, after we have a complete representation of the of our site as a graph, you can also see the content of a page at the same order as how it is structured in Sharepoint. For example, here, so for IoT manufacturing page, I just call all of the web parts based on the order, and then I'll get the complete text as it is shown in the in Sharepoint itself. And we can also take it further with LLM, like because we already have the text, and so we can pass it to LLM to create embedding and create a vector index, and then do some simple search, and also to do a multi-hop retrieval. In the third notebook, I put example of doing the simple search here. So after creating the vector index, for example, here the question is what is IoT manufacture? This is a very simple one because it is similar if we just use a vector database. So we get the result, including the score. But we can also do a more complex search using multi-hop retrieval. For example, like if I want to know who to contact for issues with cold chain monitoring system. So basically here, I'll leverage the vector index to find nodes that has a most relevant content about cold chain monitoring system, and then from there I'll get the web page that contain the web part, and then from there I'll retrieve the employees related to the web part. So this is the result. Here we only have 2 persons because essentially I can only create two accounts in my 365 account. But the idea is that the first two results is referred by IoT Asset Performance Management page with the highest score 0.74, and basically this information is retrieved after doing the multi-hop search. So finally, to summarize what I have shared for the last 15 minutes, we can leverage a Microsoft Graph API to construct a comprehensive knowledge graph from your Sharepoint site while still preserving the structure. So thank you.